Okay, last topic for chapter 10, we're going to talk about how you find the empirical and the molecular formula for a compound. So empirical formula will give you the simplest ratio of atoms in a compound. If you're talking an ionic compound, which is a metal and a nonmetal, the formula unit is usually the compound's empirical formula. For a molecular formula, which is two or more nonmetals, the empirical formula does not necessarily indicate the actual number of atoms present. So for instance, the empirical formula for diborane is BH3, but its true molecular formula is B2H6. Okay, here are your steps. So we're going to assume you have a definite quantity, usually 100 grams, of the compound if it is not given. And you'll express that mass in grams. So if it's percent, you just assume those percents are grams. You'll convert grams to moles for each element. You need at least two non-zero numbered decimal places if you can get them. And then you'll divide moles by the smallest number of moles. If the number you get are whole numbers, then they become your subscripts of your empirical formula. If they're not whole numbers, then you'll multiply by the smallest number that will convert them to whole numbers. And then these become your subscripts. All right, so we have an empirical formula that has 11.1% hydrogen and 88.9% oxygen. So our percents are going to be we're going to assume they're grams. So we're going to say 11.1 grams hydrogen, and we have 88.9 grams oxygen, times. Now these are hydrogen and oxygen are going to be part of a compound, so they're not diatomic when they're part of a compound. So we know there's 1 gram hydrogen in 1 mole. That means we're going to have 11.1 moles hydrogen. So here we can't get two non-zero numbers. And we know oxygen has 16 grams oxygen in 1 mole. So we have 5.56. So once you get your elements in the compound to moles, then you're going to divide everybody by the smallest number of moles. So in this instance, it's going to be 5.56. At this point, somebody becomes 1. So when you take 11.1 divided by 5.56, that is 2. So that means you're going to have 2 hydrogens for every 1 oxygen, so your empirical formula becomes H2O. Okay? Okay, the next one. What is the empirical formula for a compound if a 2.5 gram sample contains 0.9 grams calcium and 1.6 grams chlorine? So these two numbers added up give you that, so you don't need that. So we have 0.9 grams calcium, and we have 1.6 grams chlorine. So we know that there's 40.1 grams calcium in 1 mole. And we know there's 35.5 grams chlorine in 1 mole. So these numbers here are pulled from the table. So we're going to take 0.9 divided by 40.1. So that's going to give us 0.022 mole calcium. And 1.6 divided by 35.5, that's going to give me 0.045 mole of chlorine. So once we get everybody to moles, then you divide by smallest number of moles. So in this instance, we're going to divide by 0.22. Somebody will become 1. This is 2.04, which is really close to 2. So this says you have 1 part calcium to 2 parts chlorine, so your formula is CaCl2. Okay. If you want to put it on pause for a second and work your practice. All right, so we have 78.1 grams boron, and we have 21.9 grams hydrogen. Hydrogen has 1 gram per 1 mole. Boron is 10.8. I'm getting tired. 78.1 divided by 10.8, 7.23. So we get each of them to mole divided by smallest number. In this instance, it's 7.23. This becomes 1. 21.9 divided by 7.23 is 3. 3. So you're going to have 1 part boron to 3 parts hydrogen, so it's your empirical formula is BH3. So these numbers become your subscripts. Okay, the next one, we have a compound that contains 32.38% sodium, so that means we have 32.38 grams sodium, 22.65 grams sulfur, and the rest is oxygen. Well, your percent should add up to be 100. So to find oxygen, we're going to take 100 and we're going to minus 32.38 and 22.65. So the rest of it is oxygen, so that should be 44.97 grams. Okay, sodium's, there's 23 grams sodium in 1 mole. Sulfur, there's 32.1 grams in 1 mole. Oxygen, there's 16 grams in 1 mole. So number of moles of sodium, 32.38 divided by 23, 1.41 mole. Sulfur, 22.65 divided by 32.1, 0.71 mole. And oxygen, 44.97 divided by 16, 2.81. Okay, so now we're going to divide everybody by the smallest. So 0.71 is the smallest, so that's going to be 1. So 1.41 divided by 0.71. 1.98 is very close to 2. And then 2.81 divided by 0.71 should be 3.95, which is 4. Okay, so it's going to be Na2S and then O4. That is your empirical formula. Okay, next example. You have a 10.15 gram sample that has phosphorus and oxygen, and we know phosphorus is 4.433 grams. So to find oxygen, we're going to take the mass of our sample, which is 10.15, subtract 4.433, so that means out of that 10.15 grams, 5.717 grams has to be oxygen. Okay, phosphorus's mass is 31. Oxygen's is 16 grams in 1 mole. So we're going to take 4.433 divided by 31. So this is point, I'm going to do for some, I'm just going to do 3 on here, 1.139, I guess, 139. And then 5.717 divided by 16.357. Okay, so divide both by the smallest. Okay, so in this instance you have 2 point, maybe I should have just done 2 decimal places. Let's just do this as 14.14. Let's do this as 0.36, and we're going to divide it by 0.14. So 0.36 divided by 0.14, 2.57. Okay, so that's close enough to 2.50. I think I've made a little boo-boo someplace. So we're going to multiply this by 2 to get it to a whole number, and therefore this by 2. So this is going to become 2, and 2.25 times 2 is 5. So your formula is going to be P2O5. So your number, if it's not close enough to a whole number, multiply it by something to get it to a whole number. So like if it were 2.25, 2.33, 2.15, 2.75, multiply it by something to get it to a whole number. Okay, next topic and last topic is molecular formula, which is true formula. So if you're talking about a molecule, your empirical formula may not be the same. I'm getting weary. True formula. Okay, so true formula or molecular formula represents the total number of each element present in a molecule of a compound. It can be the same as the empirical formula, or it can be some simple whole number multiple. To find it, if you're given the empirical formula, find out what its mass is, and then take the mass of the compound, divide it by the mass in the empirical formula. That's going to give you a number. You go back to your empirical formula and multiply everything by it, okay? So let's work an example. So calculate the molecular formula of a compound. So the compound weighs 60.0 grams. And we know its empirical formula is CH4N. So we want to find out what this weighs first. So this weighs, you have 12 plus 4 for your hydrogens plus 14. So your empirical formula has a mass of 30 grams. So we're going to take the mass of our compound, which is 60. We're going to divide by the mass of our empirical, which is 30. That gives us 2. We're going to come back to our empirical and we're going to multiply everything in it by 2. So your empirical formula is going to be C2H8N2. And what you can do is you can add up these masses here in your new molecular formula and see if it equals this. So 2 carbons are 24, 8 for your hydrogens, and 28 for your 2 nitrogens. And so the compound should weigh 60, which it does. Okay, so the next one, we have an empirical formula of CH. That means its mass is 13. So we're going to take 78.110 divided by 13. So that comes out to 6. So we're going to multiply everything in our empirical formula by 6. So it is C6H6. That's your molecular. Okay. Last example. A sample of a compound with a formula mass of 34 AMU atomic mass units is found to consist of 44 grams hydrogen and 6.92 grams oxygen. Find its molecular. Okay, so obviously, hopefully you realize that you don't have an empirical formula, so we've got to find that first. So we're going to take 0.44 grams hydrogen, get it to moles. We're going to take our 6.92 grams oxygen, get it to moles. Well, luck is on our side. Our moles are pretty equal. So that means our empirical formula is HO. So now we're going to figure out its mass. So 1 plus 16, it has a mass of 17. Our compound weighs 34, so you're going to take 34 divided by 17, which is 2. You're going to come back and multiply everything in here by 2, so it's H2O2, or hydrogen peroxide. That's your molecular formula. This is your empirical. All right? Okay, this will take you through set 4 on your homework. Thank you.